देखो आता पढ़ुले जनरल मेथड ऑफ प्रिपरेशन ऑफ अल्कोहल पढ़ुले तो तीनटा जेटा मेथड ऑफ प्रिपरेशन कहितली चार नंबरटा फ्रॉम बिगिनर्स डिजाइन नंबर 4 फ्रॉम बिगिनर्स डिजाइन फ्रॉम बिगिनर फ्रॉम GRIGNARD फ्रॉम बिगिनर्स reagent from beginners reagent means alkyl magnesium halide and aryl magnesium halide RMGX alkyl magnesium halide is called beginners reagent when formaldehyde reacts with beginners reagent that is alkyl magnesium halide first an addition product is formed which on acidic hydrolysis to form a primary alcohol. Formaldehyde को बिगिनर रिएजेंट सहित रिएक्शन करेले गोटे एडिशन प्रोडक्ट फास्ट हो जब एसिडिक हाइड्रोलिसिस करले तो प्राइमरी अल्कोहल बाहर फॉर्माल्डिहाइड होची HCOH फॉर्माल्डिहाइड HCHO फॉर्माल्डिहाइड प्लस बिगिनर रिएजेंट हला RMGX so the reaction कले कोन हम देखो इटी कार्बन ऑक्सीजन भीतर कार्बन होची डेल्टा प्लस ऑक्सीजन होची डेल्टा माइनस आज ऑक्सीजन इज मोर इलेक्ट्रोनेगेटिव as compared to the carbon atom so carbon in a carbonyl group carbon atom carries positive fractional positive charge delta plus and oxygen carries a fractional negative charge in RMGX alkyl part R is 0 delta minus MGX 0 delta plus now this alkyl part comes to the carbon end this positive end and this positive part will come to the negative end oxygen atom. As a result, first an addition product is formed which can be written like this H single bond C single bond OMGX here it is H here it is R. It is an addition product which on acidic hydrolysis it is to be hydrolyzed in presence of a mineral acid H plus. This bond breaks from this H comes to this part end and OH comes to this end. As a result, R CH2 single bond OH is formed. R single bond CH2 single bond OH is formed, which is called 1 degree alcohol. 1 degree alcohol plus MgOH is formed. Hydroxy magnesium halide is formed. So it is your addition product. It is the beginner's reagent alkyl magnesium halide alkyl magnesium halide it is your formaldehyde if you take methyl magnesium suppose you take methyl magnesium chloride so when formaldehyde reacts with methyl magnesium chloride CH3 MgCl methyl magnesium chloride it is your formaldehyde when it reacts with methyl magnesium chloride carbon atom carries positive charge, oxygen carries negative charge, and methyl group carries negative charge, MgCl carries positive charge. Now, the addition product is like this H, C, single bond CH3, single bond H, O, MgCl. It is to be hydrolyzed in presence of a mineral acid H plus. This bond ruptures from this side. As a result, H comes to this side, OH comes to this side. CH3, single bond CH2, single bond OH is formed. CH3, single bond CH2, single bond OH is formed. Plus MgOHCl. It is an ethyl alcohol, which is a primary alcohol. So when formaldehyde reacts with methyl magnesium chloride, first an addition product is formed which on acidic hydrolysis to form a primary alcohol, that is ethyl alcohol. Secondary and tertiary alcohols can also be prepared by taking ingredients reagent. If you react with the acetaldehyde, suppose if you take acetaldehyde, when acetaldehyde will react with alkyl magnesium halide, that is methyl magnesium chloride, first an addition product is formed, which on acidic hydrolysis form a secondary alcohol. If you take acetone, then a tertiary alcohol will form. Formaldehyde, when it reacts with the Grignard's reagent, first an addition product is formed, which on acidic hydrolysis to form a primary alcohol. Acetaldehyde, when treated with the Grignard's reagent, form an addition product, which on acidic hydrolysis to form a secondary alcohol. Ketone, that is acetone, when it reacts with alkyl magnesium halide, first an addition product is formed, which on acidic hydrolysis to form a tertiary alcohol. Then come to the what happens when acetaldehyde reacts with methyl magnesium chloride. Acetaldehyde, when it reacts with methyl magnesium chloride, acetaldehyde is your CH3, acetaldehyde is your CH3 COH, it is your acetaldehyde. When it reacts with methyl magnesium chloride, your carbon atom carries fractional positive charge, oxygen atom carries fractional negative charge, methyl group delta minus, MgCl is your delta plus. This negative part comes to this end, positive part comes to this end. First an addition product is formed. The addition product is like this: CH3 single bond C, OMgCl, OMgCl H, single bond CH3 is your addition product. Addition product which on acidic hydrolysis, H2O in presence of mineral acid. This one next from this point. H comes to this side, left side, OH comes to the right hand side. As a result, CH3, single bond, CH, single bond OH, plus Mg, OH, Cl. This is secondary alcohol. Its common name is methyl propyl alcohol. But as it is secondary, iso is added with isopropyl alcohol. This is isopropyl alcohol, a secondary alcohol is formed. It is your methyl magnesium chloride. Methyl magnesium chloride. It is acetaldehyde. If you take acetone, suppose acetone is your CH3 CO, CH3 plus methyl magnesium chloride. Your carbon atom carries fractional positive charge, oxygen atom carries fractional negative charge, methyl group carries fractional negative charge, MgCl carries fractional positive charge. This negative and comes to this part, positive and comes to the oxygen atom. As a result, CH3, the addition product is like this: CH3 single bond C, OMgCl. Here it is CH3, here it is CH3. It is an additional product. When it is hydrolyzed in presence of mineral acid, this bond breaks from this side. As a result, it is your H, it is your OH. A tertiary alcohol is formed: CH3, C single bond OH plus Mg, OH, Cl. It is a methyl, ethyl, propyl, butyl alcohol. What is the tertiary butyl alcohol? Tertiary butyl alcohol. A tertiary alcohol is formed. When formaldehyde reacts with methyl magnesium chloride, then ethyl alcohol is formed. When acetaldehyde reacts with methyl magnesium chloride, then isopropyl alcohol is formed. When acetone reacts with methyl magnesium chloride, then tertiary butyl alcohol is formed. This is what from beginners, this is number 4. Then we come to the number 5 from alkene. Number 5 from alkene. Fifth general method of preparation from alkene. Fifth, from alkene. When an alkene is hydrolyzed in presence of sulfuric acid or phosphoric acid at 300 degrees centigrade, then an alcohol is formed. This process is called hydration of alkenes. When an alkene is hydrolyzed in presence of sulfuric acid or phosphoric acid at 300 degrees centigrade, then an alcohol is formed, and the process is called hydration of alkenes. This is also known as hydration of alkenes. Hydration of alkenes. Hydration of alkenes. When an alkene, suppose if you take CH2 double bond CH2, this is ethylene. When the ethylene is hydrolyzed, means addition of water HOH, which is carried out in the presence of sulfuric acid, which is H2SO4, or phosphoric acid, that is H3PO4, at 300 degrees centigrade, then CH, as it is a double bond consists of one sigma and one pi bond. Pi bond easily breaks, as a result H comes to the center. CH3 single bond CH2OH is formed. That is CH3 single bond CH2OH is formed. That is ethyl alcohol is formed. Ethyl alcohol. Ethylene, as ethylene is a symmetrical molecule, so ethyl alcohol. If you take an unsymmetrical molecule, suppose CH3 single bond CH double bond CH, it is an unsymmetrical compound. It is your propene or propylene. When it is hydrolyzed HOH in presence of sulfuric acid H2SO4 or phosphoric acid, that is H3PO4, which is carried out at 300 degrees centigrade. Here Markovnikov's rule is strictly followed. In this case, Markovnikov's rule is strictly followed, as it is propylene is an unsymmetrical compound. Whenever, according to Markovnikov's rule, whenever addition reaction takes place in an unsymmetrical compound, then the negative part of the addendum will go to that carbon atom which contains least number of hydrogen atom. ଯେତେବେଳେ ଗୋଟେ unsymmetrical compound ରେ addition reaction ହୁଏ, जोटा जोटा प्रथम जो लिया जाय सेटा सबस्ट्रेट, जोटा का मिसा जाय तो addendum बा reagent कहू. एटा हम सबस्ट्रेट, एटा addendum बा reagent हो वाटर. वाटर H हो पॉजिटिव पार्ट, OH हो नेगेटिव पार्ट. Then the negative part of the addendum, eta delta positive delta minus, the negative part of the addendum will go to that carbon atom. Eta sei across the double bond lagibo negative part ta out lagibo, which contains least number, that is minimum number of hydrogen atom. Your carbon atom contains, left hand side carbon atom contains a single hydrogen atom, right hand side carbon atom contains 2 hydrogen atoms. So the negative part OH minus will come to this carbon atom, which contains the least number of hydrogen atom. It's plus come to this end. As a result, CH3, single bond CH, single bond OH, single bond CH. There is a secondary alcohol is formed, which is called isopropyl alcohol. Its common name is isopropyl alcohol. That is butane, methyl ether propane, propan 2L. Isopropyl alcohol is formed. In first case, a primary alcohol is formed. If we take ethylene, which is a symmetrical molecule, where water is added in presence of sulfuric acid or with phosphoric acid at a temperature of 300 degrees centigrade, then ethyl alcohol is formed. If you take an unsymmetrical molecule, that is propylene, that is propanol, you can say propene. In this case, whenever water is added to it, then the negative part of the water, that is H in the water molecule, H is your positive part, OH minus is your negative part. Then the negative part of the adenine will go to that carbon atom. Say carbon which contains minimum number of hydrogen atoms, which contains the least number of hydrogen atoms. So negative part is like carbon it is good hydrogen it is hydrogen OH stands like CH3 single bond CH, OH single bond CH3. A secondary alcohol isopropyl alcohol. This is about from alkenes. Then come to number 6. That is from amines. That is from amines. Number 6. That is from amines. Number 6 from amines. When a primary amine reacts with nitrous acid, then a primary alcohol is formed. When a primary amine reacts with nitrous acid is your HNO2, nitric acid is your HNO3. Nitrous acid means HNO2. When a primary amine reacts with nitrous acid, that is HNO2, nitric acid is your HNO3. These two are called oxyacids of nitrogen. One is nitrous, another is nitric. In first case, the oxidation number of nitrogen atom is +3. In second case, in nitric acid, the oxidation number of nitrogen atom is +5. More is the oxidation number, more will be the acidic character. So HNO3 is stronger acid as compared to the nitrous acid. Nitrous acid is unstable at room temperature because it oxidizes when it comes in contact with the atmospheric air. It oxidizes to form nitric acid. Nitrous acid can be prepared by the action of solid sodium nitrite NaNO2 with dilute HCl. Whenever required, then nitrous acid can be prepared by mixing these two substances. One is the solid sodium nitrite, second is the dilute HCl, HNO2. As soon as it is prepared, it can be used. Otherwise, it will be oxidized to form nitric acid. So when primary amine is treated with the nitrous acid, primary amine is your RNH2. Primary amine is your RNH2 plus nitrous acid is your HNO2, which can be written as HONO. Nitrous acid HNO2. Then solid NaNO2, solid NaNO2 plus dilute HCl plus dilute HCl plus dilute HCl. Then this bond breaks like this. This is one part, this is another part. So ROH is formed. ROH is formed plus N2 plus H2. ROH is your alcohol. RNH2 is your amine. 1 degree amine. This is 1 degree alcohol. You can say 1 degree alcohol. If you take ethyl amine, your C2H5 NH2 plus nitrous acid is your HONO. It is your ethyl amine. When ethyl amine reacts with the nitrous acid, which can be prepared by action of the solid sodium nitrate with the dilute HCl, form C2H5OH ethyl alcohol C2H5OH plus N2 plus what the ethyl alcohol. So when ethylamine is treated with nitrous acid, then ethyl alcohol is born. So a primary alcohol can be prepared from a primary amine. When a primary amine is treated with nitrous acid, which can be prepared by the action with solid sodium nitrite and dilute HCl, then a primary alcohol is formed. If you take ethylamine, when ethylamine is treated with nitrous acid, then ethyl alcohol is formed. Methylamine does not respond this reaction. Methyl, if you take methylamine is CH3NH2. Methylamine does not react with the nitrous acid, HONO. When it reacts with the nitrous acid, then methyl alcohol will not form. So you have to take ethylamine. So methylamine does not respond this reaction. Then comes to the number 7, hydroboration oxidation. Number 7, hydroboration oxidation. Hydroboration oxidation. Hydroboration oxidation. What is hydroboration and oxidation? Hydroboration oxidation. Hydroboration. Borane BH3 is your borane. Boron valence 3. When boron combines with hydrogen, BH3 is formed, which is called borane. Borane, B-O-R-A-N-E, borane. It remains in dimeric form, that is B2S6, or diborane, you can say it is diborane, or BH3 whole 2, that is diborane. Diborane, D-I-B-O-R-A-N-E, diborane. Hydroboration oxidation means when an alkene is treated with diborane, then trialkyl borane is formed, which on subsequent oxidation with hydrogen peroxide in presence of an alkali, that is in presence of an alkali, to form a primary alcohol. गोटे आल्किन की नहीं डाइबोरेन सहित रिएक्शन कले मोनो आल्किल बोरेन, डाइआल्किल बोरेन, ट्राइआल्किल बोरेन हबो माने तीनटा मॉलिक्यूल सहित रिएक्शन करिवो जे तीनटा बोरेन ने एच तीनटा अछि तीनटा स्टेप तीनटा आल्किन मॉलिक्यूल नवा पड़िवो फर्स्ट स्टेप रे हमकु मोनो आल्किल बोरेन, डाइआल्किल बोरेन, फर्स्ट स्टेप रे ट्राइआल्किल बोरेन हबो ट्राइआल्किल बोरेन ता हाइड्रोजन पेरोक्साइड सहित रिएक्शन करले which is an oxidizing agent, hydrogen peroxide in presence of an alkali, then a primary alcohol is formed. This reaction is known as hydroboration oxidation. Hydroboration oxidation means first an alkene is to be treated with diborane to form trialkyl borane, which on oxidation in presence of hydrogen peroxide, which on oxidation with hydrogen peroxide in presence of an alkali to form a primary alcohol. Alkene kochi alkene likhi CH2 double bond CH2 now alkene and now ethylene meli ethylene ki react karibi diborane sahito diborane hochi BH3 half molecule hochi half B2S6 ba BH3 ro whole 2 एमती लिखि पारे बा B2S6 लिखि पारिबी डाइबोरेन BH3 रो होल 2 हाफ मॉलिक्यूल लगी तो हाफ पटले BH3 होची BH3 ले गोटा पटे H लागिबो एपटे BH2 होबो H लागि डाइबो CH3 सिंगल बॉन्ड CH2 BH2 मोनो अल्किल बोरेन तापर एटा पुणी आउ गोटे मॉलिक्यूल सहित रिएक्शन करिवो पुणी हाफ पुणे आ गोटे अल्किल सहित इथिलीन सहित रिएक्शन कले CH2 डबल बॉन्ड CH2 सहित रिएक्शन कले एटा जो CH3 CH2 रो होल 2 जीवो डाइगो BH पुणे आ सहित आ गोटे इथिलीन मॉलिक्यूल रिएक्शन कले CH2 डबल बॉन्ड CH2 डाइगो CH3 सिंगल बॉन्ड CH2 CH3B ट्राइइथाइल बोरेन it is a diethyl borane এটা monoethyl borane বা ethyl borane ethyl triethyl borane को हाइड्रोलिसिस करबा means addition of hydrogen peroxide तीनटा मॉलिक्यूल हाइड्रोजन पेरोक्साइड को in presence of an alkali नले कोन देखो एटा CH3 CH2 थिला तीनटा अछि तीनटा OH न CH3 CH2 OH तीनटा गला एटा तीनटा OH रहला एटा गोटे B रहला B तीनटा OH H3O3 H3BO3 हो प्लस H3BO3 डाला तो इथाइल आको इथाइल आको ताले एथिलीन देले केतरा एथिलीन मॉलिक्यूल गोटे एटे गोटे दुईटा एटे गोटे तीनटा एथिलीन मॉलिक्यूल मिले गोटे डाइबोरेन सहित रिएक्शन कले एटी गोटे BH3 हाफ BH3 सो गोटे रिएक्शन कले मोनो एथिलीन बोरेन डाइथिलीन बोरेन ट्राइइथाइल बोरेन ऐसाला परे हाइड्रोलिसिस करूचे H2O को मिसो ऑक्सीडेशन करूचे हाइड्रोजन पेरोक्साइड सहित इन प्रेजेंस ऑफ एन अल्काली गोटे इथाइल अल्कोहल हो तीनटा मॉलिक्यूल ऑफ इथाइल अल्कोहल हो और H3BO3 दिस इज व्हाट हाइड्रोबोरेशन ऑक्सीडेशन देन लास्ट वन इज योर oxymercuration and demercuration number 8 oxymercuration and demercuration oxymercuration and demercuration oxymercuration and demercuration oxymercuration and demercuration number 8 oxymercuration and demercuration when an alkene is treated with mercuric acetate in presence of water then hydroxymercurial compound is formed which on subsequent reduction to form an alcohol गोटे alkene नबा गोटे alkene के हम ट्रीट करबा mercuric acetate आ वाटर सो mercuric acetate आ वाटर सो ट्रीटमेंट करले गोटे mercuric then hydroxymercurial compound गोटे हो गोटे hydroxymercurial compound हो आ से hydroxymercurial compound फर्दर रिडक्शन आउ द रिडक्शन करले से गोटे अल्कोहल हो गोटे डबल बॉन्ड अल्कीन नै छै गोटे डबल बॉन्ड कंपाउंड में C डबल बॉन्ड C एटा गोटे अल्कीन दे गोटे अल्कीन ले अल्कीन के मर्क्यूरिक एसिटेट आ वाटर सॉल्यूशन से रिएक्शन करबा वाटर हला H2 मर्क्यूरिक एसिटेट हला Hg CH3 CO CH3 CO CH3OOC it is your mercuric acetate से रिएक्शन करले अल्कीन ले अल्कीन वाटर मिसले mercuric acetate जो HgOOC CH3 OOC जो mercuric acetate सॉल्यूशन से रिएक्शन करले कोन हो गोटे मर्क्यूरियल डेरिवेटिव हो मर्क्यूरियल डेरिवेटिव हो मर्क्यूरियल डेरिवेटिव हो माने ऑक्सीमर्क्यूरेशन प्रोसेस को जाए ऑक्सीमर्क्यूरेशन ऑक्सीमर्क्यूरेशन हेले कोन हो ए डबल बॉन्ड थिला सी रहिला एटा सिंगल बॉन्ड हे जिवो सी हे जिवो सी ऑक्सीमर्क्यूरेशन हेले OH ग्रुप लागिला एटा सी रहिला 1 2 3 आगो जगह तुम लगे मर्क्यूरिक एसिटेट Hg OOC CH3 मर्क्यूरिक एसिटेट मर्क्यूरियल एसिटेट हला एटा को हमें रिडक्शन करबा इन प्रेजेंस ऑफ सोडियम बोराइड्राइड NaBH4 और टेट्राहाइड्रो एटा नै परबा बट THM नै परबा टेट्राहाइड्रोफुरान एगो रिडक्शन करबा एगो रिडक्शन कले एटा इबो C एटी तुमर OH रहिला एटा C H जिवो एटा गोटे अल्कोहल गोटे अल्किन दे नै दिले गोटे अल्किन नै दे जदी CH प्रोपीन नै थाले CH3 सिंगल बॉन्ड CH डबल बॉन्ड CH2 प्रोपीन नहीं थांते प्रोपीन की वाटर प्लस मर्क्यूरिक एसिडेट से रिएक्शन करतांते OOCCH3 मर्क्यूरिक एसिडेट से रिएक्शन करतांते मर्क्यूरिक एसिडेट से रिएक्शन करतांते मर्क्यूरिक एसिडेट से रिएक्शन करैला परे लिखुची ऑक्सीमर्क्यूरेशन ए प्रोडक्ट बार दंदा तापर तो रिडक्शन करतांते NaBH4 THF एटा बाटा ट्राइडर पुरान देई तो मोर हे धंदा CH3 CH OH CH3 प्रोपान 2L और आइसोप्रोपाइल अल्कोहल प्रोपान 2L तो एटा ऑक्सीमर्क्यूरेशन ए फर्स्ट प्रोसेस है जो ऑक्सीमर्क्यूरेशन एटा डीमर्क्यूरेशन प्रोसेस है डीमर्क्यूरेशन this is about the general methods of preparation of alcohols.